The next problem is to sketch the curve by eliminating the parameter and indicate the direction of increasing t. So we are given the parametric representation x equal to 3t minus 4 and y equal to 6t plus 2. So from this we will get, so we have x equal to 3t minus 4. So therefore t will be equal to x plus 4 by 3. So let us substitute this t value into the second equation. So therefore y will be equal to 6 x plus 4 by 3 plus 2. So that will be 2x plus, so this will cancel out, 2 will come, so 2x plus 8 plus 2. So therefore the equation is y equal to 2x plus 10. And now that will be a straight line. So let us look at what is the direction of increasing t. So for that we will give sample values of t. So we have x equal to 3t minus 4 and y equal to 6t plus 2. So let us look at how the points are being traced. So if I take, say for example, t equal to minus 2, then xy will be equal to minus 10 varum, then y value will be again minus 10. So if I take t equal to say minus 1, then xy is going to be minus 7, then minus 6 plus 2, so that will be minus 4. And if t is 0, xy will be minus 4, 2, and if t is 1, then xy will be uh, 3 minus 4, so that is minus 1, 8, and if t is equal to 2, then xy will be 2, and then we will have 40. So those are a few points, so we can look at what is going to be the direction. So when t is 2, so you have the point, so let this be minus 10, minus 10, then we'll have minus 7, minus 4, and then we'll have minus 4 and 2, so somewhere here, and then we'll have minus 1, 8, and then we'll have 2, 14, that will be here. So that is going to, so we join all the points, you can see it will be the line, so which we have got. So this is the direction. So as t increases, it is moving upwards. So the line is being traced upwards, not in the downward direction. So this is how we obtain the required curve. So we have eliminated the parameter. So the curve is y equal to 2x plus 10. So as t increases, the curve is moving in the increasing in the forward direction. Now let us look at another example. So if you have x equal to 2 cos t and y equal to 5 sin t, where we have 0 less than or equal to t less than or equal to 2 pi. So here when you take x by 2 is cos t and y by 5 is equal to sin t. So we have cos square t plus sin square t equal to 1. So that will give x square by 4 plus y square by 25 equal to 1. So this is an ellipse. So the given parametric representation that denotes an ellipse. So let us look at what is the orientation. So when t is 0, xy is going to be equal to 2, 0. T equal to pi by 2 വരുമ്പോൾ xy will be 0 and 5, when t is pi, xy will be pi വരുമ്പം minus to 0 വരും. Then t is 3 pi by 2, so in that case xy will be 0 and minus 5, and when t is equal to 2 pi, we will have xy equal to again 2 0. So here you have the starting point as 2 0, then 0 5 varum, then minus 2 0, and again 0 minus 5, and back to the point 2 0. So this will be ellipse. Okay. So this is going to be the equation, and the curve is being traced in the anti-clockwise direction. So the orientation is so as t increases from 0 to 2 pi, curve is traced in anti-clockwise direction. Just look at how to find the derivatives of the parametric curve. ഇതൊക്കെ നമ്മൾ already ചെയ്തിട്ടുള്ളതാണ് differentiation. So if you have x equal to x of t and y equal to y of t, then dy by dx will be given by dy by dt by dx by dt, and if you want d square y by dx square, that will be equal to d by dx of dy by dx. So that is, by chain rule you can write it as d by dt of dy by dx into dt by dx. So that is how we evaluate the first and second derivatives of the parametric curve without eliminating the parameters. So we are getting the value of the derivatives in terms of t. So നമുക്ക് Cartesian equation കണ്ടുപിടിക്കേണ്ട ആവശ്യമില്ല. So we can evaluate the derivatives in terms of t itself, and again here d, when you have a parametric curve x equal to x of t and y equal to y of t. So dy by dx represents the slope of the tangent line to the parametric curve. So this is how we obtain the slope. So let us look at few examples for finding the derivatives. So find dy by dx and d square y by dx square without eliminating t. So ഇതൊക്കെ നിങ്ങൾ നേരത്തെ പഠിച്ചിട്ടുള്ളതാണ്. We are just refreshing that only. So if you have x equal to root t and y equal to 2t plus 7, so find dy by dx at t equal to 1. So we have dx by dt equal to 1 by 2 root t, and dy by dt is equal to t. So therefore dy by dx will be dy by dt by dx by dt, so that is going to be 2 by 1 by 2 root t, so that will be 4 root t. So therefore dy by dx at t equal to 1 is going to be equal to 4. Now next you need d square y by dx square, so that is d by dx of dy by dx, so that is d by dt of 4 root t into dt by dx. So that will be 4 into 1 by 2 root t ഇനി dt by dx എന്ന് പറയുന്നത് 2. So that is equal to 4. So therefore d square y by dx square that is equal to 1. That is equal to 4. So that is the required derivative. X equal to theta plus cos theta and y equal to 1 plus sin theta. So let us find the first and second derivative. So dx by d theta will be 1 minus sin theta varum, and dy by d theta will be equal to cos theta. So therefore dy by dx is cos theta by 1 minus sin theta varum, and if you want d square y by dx square, that will be d by d theta of cos theta by 1 minus sin theta into d theta by dx, so that is 1 by 1 minus sin theta. So upon using quotient rule, you will get 1 minus sin theta whole square, 1 minus sin theta into cos theta derivative minus sin theta minus cos theta into minus cos theta 1 by 1 minus sin theta. So in the numerator, so that will be equal to minus sin theta plus 1 varum by, okay, it is 1 minus sin theta whole cube. So that is going to be equal to 1 by 1 minus sin theta whole square. So that's the value of d square y by dx square. So therefore at theta equal to pi by 4, so dy by dx will be, so we get 1 by root 2 by 1 minus 1 by root 2. So that is 1 by root 2 minus 1. അതുപോലെ d square y by dx square will be 1 by 1 minus 1 by root 2 whole square. So we will get 2 by root 2 minus 1. So those are the value of derivatives that we are given.